Okay, let's begin. So, first sort of thing that I kind of want to get started with is talking about what electrostatics even means, because it's a huge topic in electrical fields and forces. So I'm really just going to take Mr. Ahmed's notes today and really dissect them. I think it's easier to learn if someone teaches it to you anyway. So let's take a look at what electrostatics even means. So electrostatics is the study of electrical forces. And if you break down the word, you can see that it comprises of two different words. The first word is the word electro. And when we refer to the word electro, we're talking about the electric charge. And the second word is the word statics. Now, when we talk about statics, we're talking about the word itself, and it means at rest. So this word static means at rest. So altogether, electrostatics basically means the study of electric charges when they are at rest. It means that they're not flowing through a wire, there is no continuous movement of electric charge, and instead it's just that static charge exchange or transfer that's going to be happening. So when we're talking about charges, we need to know what type of charges there are and what our particles consist of in all matter. So the first one is the electron, and the electron, we all know it as the smallest particle, and it has that -1 charge. So when we're looking at an electron in an actual atom, it's going to be the smallest in terms of mass and size, and it's going to control a lot of the stuff that we look in terms of electrostatics because of its size. So the next one is the proton, and the proton has that +1 charge. It's a lot bigger in terms of relative mass. If we think about it in terms of the electron, the proton has a much larger mass. So relative to the mass of an electron, which let's just say it's 1 gram, it is 1,836 times as much as the mass of an electron. So when we're thinking about a proton, it's actually a lot harder for us to see it moving, and that's why electricity is mostly going to be controlled by the electrons. And then the very last one, it's not necessarily a charge because it's neutral, but it is a neutron, and once again, it's neutral, so it doesn't have a charge, no +1, no -1, nothing like that. It is just simply denoted as a 0. Sometimes people will kind of like, when something is neutral, they'll draw this symbol out, like with the N and the 0, just making sure that it's a charge. With the electron, it looks something like this with the E and the -1, and with the proton, it looks like this with the P and plus sign at the top. And once again, the neutron doesn't really do much movement. It is one of the bigger particles in the nucleus, and it looks a little bit bigger than the proton because it is just maybe 3 grams more in terms of that relative size based on that electron. But basically, yeah, what we've seen so far is that the electron is a lot smaller than the proton, and so they can be moved or removed way easier, way faster than protons could ever be. So when we're thinking about electrostatics, we're really looking at the electrons, and we're looking at how quickly or how easily they can be moved. And in chemistry, that's what we call electronegativity, how matter can snatch those electrons and how strongly they could do that. So when we're thinking about the positive charges, they're always going to stay in this nucleus region within an atom. So let's just say this is a hydrogen atom, and this is the nucleus. The positive charges and the neutral charges are going to stay in that nucleus, where the electrons are going to kind of buzz around the atom. So when we think about electrostatic charges, we're thinking about it in terms of electrons. We're thinking that the excess of electrons, the negative charge, is going to be in that entire object if there are more electrons. And if there are less electrons, there's going to be a deficit, leaving it overall positive.